Hey everyone, welcome back to the Cosmic Frontier. Today, we're diving into the incredible and explosive lives of the most massive stars in the universe. Space is vast and full of wonders. Among the most awe-inspiring events are supernovae. These cosmic fireworks mark the explosive death of massive stars. Imagine a single star, brighter than an entire galaxy, shining for a brief time. That's a supernova. Supernovae are not just visually stunning, they are crucial to our understanding of the universe. These explosions release vast amounts of energy and matter, shaping galaxies and seeding the cosmos with the building blocks of life. The iron in your blood, the calcium in your bones, these elements were forged in the heart of dying stars. Understanding supernovae helps us unravel the mysteries of stellar evolution and the origins of the universe itself. We can trace our own cosmic lineage back to these powerful events. In a very real sense, we are all made of stardust. From their incredible brightness to their role in creating the elements necessary for life, supernovae are a testament to the power and beauty of the cosmos. Stars, like our sun, are not eternal. They have a life cycle, just like living organisms. Massive stars, many times larger than our sun, live fast and die young. These celestial behemoths burn brightly and exhaust their fuel quickly. A star's life is a constant battle against gravity. The immense pressure at its core forces hydrogen atoms to fuse into helium, releasing tremendous energy. This nuclear fusion is what makes stars shine. Massive stars have much more fuel, but they burn it at an accelerated rate. Over millions of years, massive stars convert hydrogen to helium in their cores. As the star ages, heavier elements like carbon, oxygen, and eventually iron are created through further fusion reactions. Each stage of fusion releases less energy, and the star's core contracts further. The lifespan of a massive star is much shorter than that of our sun, which will live for billions of years. These stellar giants race through their fuel reserves, setting the stage for a spectacular demise. Iron is the final product of fusion in a massive star's core. Unlike lighter elements, fusing iron requires energy rather than releasing it. This creates a crisis for the star. Without the outward pressure of fusion, the core can no longer support the weight of the star's outer layers. Gravity takes over, and the core collapses in on itself at an astonishing speed, approaching a quarter of the speed of light. The core, now incredibly dense, resists further compression. This sudden halt creates shock waves that reverberate through the star. The infalling outer layers of the star slam into the rebounding core, generating unimaginable temperatures and pressures. This collision of forces triggers a runaway nuclear reaction, unleashing a truly mind-boggling amount of energy. The stage is set for one of the most powerful explosions in the universe, a supernova. The energy released in a supernova is almost incomprehensible. For a brief time, the dying star can outshine its entire galaxy. This brilliant flash of light is what we observe as a supernova. The explosion propels the star's outer layers into space at incredible speeds, creating a shockwave that travels outward. This expanding shell of gas and dust, called a supernova remnant, can be observed for thousands of years after the initial explosion. Supernovae are not just visually spectacular, they are also incredibly powerful events. The energy released can rival the energy output of an entire galaxy over its lifetime. These explosions have profound effects on their surroundings, shaping the interstellar medium and triggering the birth of new stars. The death of a massive star is truly a sight to behold. It is a reminder of the immense power and beauty of the cosmos and the constant cycle of creation and destruction that governs the universe. Section 5. Stellar remnants, neutron stars, black holes, and more. After the dazzling display of a supernova, what remains of the once mighty star? The answer depends on the mass of the original star's core. If the core's mass is about 1.4 to 3 times the mass of our sun, gravity crushes the core into a neutron star. These incredibly dense objects are only about 12 miles across, but a teaspoon of neutron star material would weigh billions of tons on Earth. For cores exceeding 3 solar masses, gravity's pull is even more extreme. The core collapses indefinitely, forming a black hole. These enigmatic objects are so dense that nothing, not even light, can escape their gravitational grasp. Supernovae also leave behind stunning nebulae, vast clouds of gas and dust enriched with heavy elements. These remnants provide astronomers with valuable clues about the supernova explosion and the star that created it. The remnants of supernovae are as fascinating as the explosions themselves. They offer glimpses into the extremes of physics and the ultimate fate of massive stars. Cosmic alchemy supernovae as element factories. Supernovae are not just agents of destruction, they are also engines of creation. The intense temperatures and pressures during the explosion allow for the fusion of elements heavier than iron. This process, called supernova nucleosynthesis, is responsible for creating many of the elements found on the periodic table. The elements forged in the heart of dying stars are scattered throughout the cosmos by the supernova explosion. This material enriches interstellar clouds of gas and dust, providing the raw ingredients for new stars, planets, and even life. Without supernova, the universe would be a very different place. The heavy elements that make up our planet, our bodies, and everything around us would not exist. We owe our very existence to these cosmic explosions. Supernovae are the universe's grand recycling program, transforming death into new life and seeding the cosmos with the building blocks of complexity. The connection between supernovae and life on Earth is profound. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were created billions of years ago inside massive stars that ended their lives as supernovae. These elements were scattered into space, eventually becoming incorporated into the cloud of gas and dust that formed our solar system. Without supernovae, our planet would be a barren rock, devoid of the essential ingredients for life. Every breath you take, every beat of your heart is a testament to the incredible power of these cosmic events. We are, in a very real sense, children of the stars. Supernovae remind us that we are not isolated beings but part of a vast and interconnected cosmos. The atoms in our bodies have journeyed across billions of years and light years, carrying within them the echoes of stellar explosions. A universe transformed, the lasting impact of supernovae. Supernovae are not just isolated events. They have a profound and lasting impact on the evolution of galaxies and the universe as a whole. The shockwaves from supernovae can compress nearby clouds of gas and dust, triggering the formation of new stars. In this way, supernovae play a crucial role in regulating star formation within galaxies. Supernovae also inject energy and heavy elements into the interstellar medium, shaping the chemical composition and evolution of galaxies over billions of years. These explosions are essential for creating the conditions necessary for life to arise. Even on a cosmic scale, supernovae are forces to be reckoned with. They are powerful reminders of the dynamic and ever-changing nature of the universe. Our place in the cosmic dance, a final reflection. As we contemplate the awe-inspiring power of supernovae, we are reminded of our place in the grand scheme of the cosmos. We are part of a vast and interconnected universe, where stars live and die, scattering the seeds of future generations. The atoms in our bodies were once part of stars that burned brightly billions of years ago. We are literally stardust, connected to the cosmos in a profound and intimate way. Supernovae are not just distant events, they are an integral part of our cosmic story. They remind us of the beauty, power, and interconnectedness of the universe we inhabit. As we continue to explore the cosmos, we can be sure that new discoveries will further illuminate the profound impact of these stellar explosions on our existence and the universe we call home. Thanks for joining me on this stellar journey today. If you enjoyed learning about the life and death of these massive stars, don't forget to like, subscribe, and hit the bell icon so you never miss out on more cosmic content.